Yeah, hi everyone. So I guess just to start, if you could mute your microphone if it's not already muted so we don't get like your background stuff going on, and then just unmute it if you have questions or stuff. So yeah, thanks Jake for the introduction, and I'm Maya. David is also presenting today, and his screen has all of the supplies. There's his thumb. So I guess before we get started, I was curious, do we have some like younger students on the line here? I guess you're all muted. Quick unmute and say yeah if you're under 18.
There's a 5-year-old.
Yes.
Yes.
Awesome.
Cool. All right, great. Well, like Jake said, we are from FirstHand, and so we've been really bummed in the past month and a half to not be like doing fun science activities in our lab. So we figured we'd see what we could do and try one out right now. And so we figure soap's pretty important. You've probably all been washing your hands a lot. I know I have. So we figured we'd kind of think about why that's helpful right now and what a little bit like of the science behind soap. So I want to start with a picture for you. Can everybody see that?
Yep.
Cool. Okay, so this is the greasiest, nastiest pan, right? And there's only really one solution here, right? So like you could dump a bunch of water in it, but it would still be greasy. You could just kind of rub your hands around in it and then your hands would be greasy. You could even rub a sponge on it, but it'd still be greasy. What you need is, everybody, soap, right? You need some soap. But why does soap actually work? And we're going to talk about why it's important for like greasing, for like getting the grease off your pan. And it's as important during this SARS-CoV-2 pandemic. It's kind of the same principle that we're going to kind of figure out why it's so cool. So, oh, can I not? And it's because of the power of soap molecules. They actually are able to bond to bacteria and viruses in addition to that bacon grease or that hamburger grease that's in your pan, right? So here's a really fancy drawing of a kind of crude soap molecule. The most important thing that we're going to talk about today and in the demo that you actually do is that there's two really fancy science words. One's called hydrophilic, like Philadelphia, and it means you're really into water. Hydrophobic means that you're like, I am not about water, right? You avoid water at all costs, right? So this is really important because soap, as you can see in this diagram right here, has that blue head. So soap actually has a hydrophilic head, which means it's like really interested in bonding with water, and its tail is like, water, get out of here. I want something that's fatty. Wait, what's fatty? The bacon grease that's in your pan. What else is fatty is the coronavirus molecule, right? So this orange part here, and even these red proteins right here. So the tails of the soap are really into that. Now, I know this diagram's kind of like, oh, whatever. So instead, I just want to remind you here, this is a little bit more fun, right? So these are the soap molecules. You have the head that's like really into water. So you turn your faucet on, it's really into water. And this tail's like, where's the fats? I want the fats. And when you go out into the world, and if you happen to get any kind of any virus molecules on your hand, a virus molecule like this, right? You go home, you wash your hands immediately, and there's soap covering your hand. And it actually, the tails are like, where's the fat? Where's the fat? And they actually destroy the molecule itself and start pulling apart the proteins and encircle them. And when you remember your faucet's still going, and it's going straight down your drain. So this is why it's so important to wash your hands as much as possible during the SARS-CoV-2 pandemic, because the soap actually physically tears apart the virus molecules.
Why is it so important to us?
Along with bacon fat and things like that. So we're gonna move on to David's STEM lab at his house. I'm going to pass it off, and if you have any questions, you can ask me after the demo. So I hope you guys have your stuff together, and I'm going to pass it to David.
Hey, Science Center family. So I just want to reiterate what Maia was just talking about. She was talking about how soap has two molecules inside and how one side is attracted to water and then one side is also attracted to the fats. So like the grease and the grime in our pots and our pans, and even some of the dirt that's actually on our hands. So given the COVID-19 situation, we've been advised that you should definitely
what they've been up to.
We've been advised that you should definitely wash your hands for approximately 20 seconds with soap and water, preferably warm soap and water. So we're going to move on to 3 quick demos, and then I'm going to show you all how to make a soap-powered boat real quick. The first demo is just, here's a little vial, and there's some water in the vial. I'm going to add some oil to this, and we're going to show the separation of water and oil, and then also what happens after you add some soap to this.
Sorry, David, real quick, I just want to jump
Sure.
in. If everyone scrolls to the top of the video window and you see David's video with all the supplies, if you right click on that, you'll see an option that says Spotlight Video, and that will pin David's video to the center screen. So we won't have any jumping back and forth. So if you can do that. All right. Sorry, David. Thanks.
Oh, all good. Thanks. Okay, cool. So originally our vial just had some water. Now I added some oil to it. And I'm going to shake this up. And what you're going to notice is the oil is going to float directly to the top. You're going to see a small separation start to form right here. And this is without, this is right there. This is without any soap added to this mixture. So we're going to show you all what happens when you add some soap to some water and some oil, and how the soap sort of takes control.
How long part of the book?
That's ridiculous. You knew better than that.
So quickly, within a couple seconds, you see that the oil is totally taken over by the soap. The soap bonds to the oil, and it also bonds to some water. Those two awesome molecules. And that's the first little demo. So moving forward, a lot of people have like seen this experiment where you just have like a paper plate, and you have some water on the plate. And what I'm going to do is I'm going to add some grounded black pepper to this environment. This is about 3 teaspoons of black pepper. And then with a Q-tip, I'm going to dip my Q-tip in some soap. And we're going to see how soap responds to this environment by simply taking the Q-tip and dropping it in the very center. Ooh, 1 second. Ooh, interesting. All right, so what's supposed to happen is the soap is supposed to separate the black pepper, and the black pepper is supposed to move to the sides of the paper plate. But we either have too much black pepper or we're not using, I guess, the proper soap with this experiment. So let's just move on to the second to last part. This is probably the coolest part, actually. Cool. So we have some milk right here. And this demos the prior experiment, but hopefully it shows out a lot better in comparison. So I just have some whole milk right here in this bowl, and I'm going to add a couple drops of food coloring. So the food coloring is pushed to the outer perimeter of the bowl. And this just shows how like soap interacts with like any environment that has like a pigment or some dirt. The pepper would have been like a really, really, really great explanation, but it didn't actually quite work out too well.
What happens when you add it again? Because can you make art with this for the people who are watching?
Oh, let's try it real quick. That's a great question. So yeah, a little bit. I think I would suggest getting another Q-tip, making sure it's totally clean. It's best if the Q-tip didn't interact with any water or anything beforehand. And of course, dip it in some soap.
So this is a cool thing that if you guys have some milk and food dye, you could spend like a half an hour kind of just making really cool designs because the soap is forcing the food dye in different directions like that.
Cool. All right, anything else you want to add, Maya?
Oh, that's good.
Sweet. All right, let's move on to how to make a boat. So the boat experiment was like really fun. It was a lot of trial and error actually, because you have to like figure out, does cold water work better? Does warm water work better? Does really hot water work better? And then also I experimented with different types of soap. So right here, I just have some traditional like dish soap. So if you want to clean a pot and a pan within your kitchen, this is great soap. I did try it with a little bit of body soap. So like picture like Dove, like a Dove bar, but broken down just a little bit. The best response was in warm water, and it was actually with dish soap. So the water doesn't necessarily need to be like boiling, but out of the faucet, it should be a little hot. And you tend to get the best response. So let me just clear off this station real quick. Cool. So I'm going to start off with the supplies that I use for this. The first, again, is some traditional dish soap. It is kind of awesome to have a ruler standby if you want to make sure you have the correct metrics for your boat design. A scissor or X-O knife is really, really helpful. And another big part of trial and error was trying to figure out like what material to make the boat out of. Cardboard, even business cards, was a little tough because it absorbs water to a certain degree. So we elected to use styrofoam from a styrofoam plate. It's easily to find in your household, and we just suggested focusing on the center part of the plate, so the outer perimeter, just cut it away. And I like to start off with the metrics, but just give me one more minute. Q-tips is the second to last item you need at your station, and some ground black pepper if you want to add ground black pepper to the environment when you have your boat moving around. Cool. So first things first, we need to cut out a boat. And we don't want our boat to be too big, but we want it to be like big enough to operate in this environment. So about 2 inches is like a great size for the boat. And I'm gonna start off with the ruler.
And if you guys have the supplies, you can join along with David, or you can watch and we'll give you a chance to make it on your own and show us what you got.
Oh. So I'm just gonna cheat just a little bit. I already have a boat designed right here. It's best that the boat has this type of shape at the back of it. There's really no sizing parameters for like how big or how small to make it. as long as you stay within like 2 inches to 3 inches for the overall size of the boat. And what's really important is making sure you do have a tip at the very top. So if you need to alter the overall design of the boat just a little bit so that you make sure that you have that like pointed tip, that is really, really important. Cool. And it's totally okay if you're not an artist. The team knows like my artistic abilities are like, they're not there. So crafting this, it doesn't have to be totally perfect. You don't have to like stress yourself out about it. You may encounter a little bit of trial and error based off of the size of the boat. And then also the placement of the soap. So, and we're gonna discuss placement of soap right now because it's pretty important. Cool, so. All right, I have 2 little boats right here. The water is still a little warm, so that's great. Some people elect to use a toothpick. I'm gonna elect to use a Q-tip because Q-tips are great. It really absorbs a lot of the soap and helps with the placement. In my trial and error, in my hypothesis, I kind of seen that it's best not to have soap at the very bottom where the boat is going to touch the surface of the water. It's great to have some soap in this corner right here on both sides. So with that in mind, what I'm going to do is I'm going to take this Q-tip and I'm just simply going to paint some soap in this area.
David, can you tilt it so we can see where you're putting it exactly? Yeah.
Of course.
Okay.
Cool. And you have a boat that moves for a couple seconds. It's great to make another boat. I've learned that you can totally reuse the boat, just take it out of the water with like a cloth, dry it off thoroughly, and then add some more soap. If the water seems to get cold, try to get some more warmer water. You get a better response. The whole logic of washing your hands with warm water and soap really applies to this experiment. And yeah, I'll let it run a couple more times so we can see it. And I'll even add some pepper to the environment and see if we get a sort of moving reaction.
Yeah, so these are kind of David showed you a couple of different things here. So you can try out, I think if you just use less black pepper, it should kind of scatter. You can try the milk and food dye, or you can try cutting out the boat and seeing if you can get it to move with how much soap you add, more or less, and even then adding your Q-tip into the soap lake, right? So I think David's gonna play around, but if you guys have supplies in front of you, maybe you can share your camera and show us what you're working on so we can kind of all see what each other are doing. Because I know we only have about 10 minutes left. So
and if you have questions, feel free to ask questions too.
Yeah, so you can also you can chat in the chat box, or you can just chat to us because we're just hanging out now.
Yeah.
And Melissa says in the chat, David, if we put a little pepper on the water, will the pepper move in the same direction as the boat? So we can just try sprinkling a little on there.
Okay. It's interesting. And what I'm seeing right now is once you add pepper to this environment, it sort of clumps together since you've already had a little bit of soap in here as well. So you see that? Like, I'll try it again real quick. So it just like clumps together. Let's try another boat.
When we were brainstorming for this, we were like, I wonder if you could make the boat seem like Pac-Man and it can just gobble up the pepper. If you can control the boat in a way that you can add soap to get it to go closer to the pepper, which is hard because if the boat has soap on it and it's scattering away from the pepper, it's a real chase right there.
Yeah.
Is anybody doing this along with us out there? If you're
I think my water's a little too cold, maybe.
Yeah, mine's is getting cold, so it's definitely giving me like a really slow reaction time. You said we have about 10 more minutes, so I can go grab some warm water.
Okay, go for it. And Jake, do you have I think it should work with like lukewarm water too.
Yeah, lukewarm is the best.
The other thing you can do if you have pipe cleaners and construction paper is make soap molecules.
Ooh, yes, just like Maia's experiment. That was really cool.
My new puppet dance. You and your friends can make a puppet version of what happens when you wash your hands.
I did enjoy those quite a bit. Where did you guys first hear about this experiment? Is this something you've done with your students or just as of recently?
Well, the experiment's I've heard about it like, years ago, but it had nothing to do with, coronavirus because that wasn't a thing then. So it's more about just like it's sort of like invisible forces. It's a lot more about surface tension because, when you see those water striders moving across the water, they're able to do it because of the way water bonds, right? And that there's this sort of film that has surface tension, and soap breaks that surface tension because we know now that it's like the molecule has these sort of two dual parts that are kind of opposing in when it reacts with water. So it was always a surface tension demo, and still is, right? That didn't change, but now it has an added sort of component to it. Do I see Rochelle and Phil there on the call? Are you guys doing the demo? Calling you out.
Yeah, you're calling me out. No, unfortunately, I'm not. I'm just watching.
That's cool. Thanks for being
here. Yeah, it's fun.
David, I wonder too if the fineness of the black pepper has to do with how easily it scatters. Because you had glitter. Do you still have glitter?
Yeah, I still have glitter.
Let's try glitter versus the black pepper just to see. Because that's bigger flakes. They're heavier, but.
I have green glitter. That's like thick.
Ooh, yeah, look at that. Kind of blends in. It's a little hard to see, but maybe you can describe what's happening.
Yeah, it's a little hard to see. I'm gonna move this up just a tad bit. Cool. Okay. So it's a little hard to see. You can see a lot of it clumped up in the back area. This water is like lukewarm, so hopefully we get like this super awesome response.
What if you just put the toothpick in first? Can we just see what happens there?
Sure, just give that a go. I'm gonna pick this end.
There it is.
Nice.
It's cosmic.
Cool. All right. So before the soap reaches the other end of the of the tray, I'm gonna add some soap to a boat.
Just sailing on Glitter Lake over there. And then I wonder if you can actually use the Q-tip to keep it propelling forward by touching sort of around. I don't know if it would be in the center. What if you touch it in that, like where the wedge is? Does it actually propel it in any way? Well, actually, like on the water, does it move it?
Oh, like actually look.
Yeah.
Um,
I don't know. I'm just experimenting
this is
for you
great.
now. Ooh, Phil's got a container and a plate.
Here we go.
Hi.
Iva said her boat works. Nice.
Not really.
Yeah. Nice.
There you go.
Nah.
No, because there's nothing to really repel it at anything.
Yeah, and I also think once you've added soap to the environment, the
Mhm.
whole environment is sort of like tainted already. It's like
Yeah.
there's soap there. So I've noticed like a totally different response after soap is already there.
Yeah. Also, I want to add from the chat earlier while David was sharing like how the how-tos, Angela McQuillan brought up a great point with the milk and food coloring. She suggested that once you have a kind of design that you actually just put a piece of paper on top of, like lightly, like a piece of notebook paper or something on top of it, and then peel it off and see if the print of the food coloring is a print of your like Power of Soap demo, which I think is a cool idea. It's like marbling.
That's smart. Like line paper probably would be like really awesome, right?
Yeah, I think any kind of like light paper, you could,
Okay.
it would probably drip down a lot, but it could be a cool look.
Nice. Cool.
Yeah, I see Phil doing it now too. So if you guys have questions, you can also, we're on the internet. You can follow us at FirstHand Philly. We do some of these demos on Instagram. So yeah, follow us for more of these and share what you're working on too, because I'm sure you're getting kind of bored out there thinking about how things work. So.
Yeah. And we're hoping to post this on Instagram sometime this week.
Great, yeah.
Does anybody have any questions for us before we? Oh, I want to see Phil and crew.
I want to see.
So yeah, if you have glitter too, what other things worked well, David? Glitter, pepper.
Glitter, pepper work good. Anything that's a pigment, so anything that's like flaky, like even other like I guess salts that have like a thicker pigment, like this glitter is like really visible, so it's not like super thin or super micro. They work great in this environment. What else?
Paint's probably too heavy, or
Yeah, paint's a little too heavy. I'd be interested to see like oil at this level. Like I know we've seen oil in this bottle, but like oil on the tray-like environment with the boat, I'd really be curious to see that.
and with pepper, yeah.
Yeah.
Ooh, there it is. Phil, check out Phil Brooks's. Yeah, nice cutout, nice fast cutout.
Cool. Well, I think that's our time.
Yeah.
Yeah. Thank you, Maia and David. Really appreciate you guys showing off your science for us today.